Hello everyone and welcome to this Python NumPy tutorial for beginners. Please note that this video is part 2, and if you haven't watched part 1 already, I highly suggest you watch that video first. In part 1, I cover the following. I explain how to familiarize yourself with Jupyter notebooks and how to run them or create new ones, how to import and install packages, how to manually create NumPy arrays, and how to use the existing NumPy functions to create NumPy arrays. I also explain from where to download this Jupyter notebook in case, without the code, in case you do want to apply what you see in this video yourself and actually learn. This is the best way of learning, by applying what you see. In this video now, what we're going to cover is the following: how to index the arrays, the data types of the arrays, how to apply maths using NumPy arrays, and how to use the mathematical functions that NumPy provides, how to reshape, transpose, and broadcast. Right, so the first thing we're going to do is the array indexing. So we scroll down to array indexing. Again, watch part 1 to learn all of the above. The first thing we want to do here is to create an array first before we start indexing it. So we can say a equals np dot array. Actually, I want a random array 3 by 5, so I can do this quickly by using random, and then I can say 3 times 5, and then if I run a, we can see random is 0s to 1, so I can do times 100 to get solid numbers, and I can say a dot round to 2 to remove the decimal places to 2. So if I run a now, again, we can see we have a 3 by 5. So if I run the shape, a dot shape, oops, I don't need the brackets. We can see that we have 1, 2, 3 rows, 1, 2, 3, 4, 5 columns. So to index this now, let's just say a square brackets 2, 0, and see what we're going to get. We get number 52.14. So 5214 is actually this number here. So the way it works is that, remember, the first number, which is the row, starts from 0. So it does 0, 1, and then 2. And then take 0, which is the first number. So 0, 1, 2, 3, 4. So 0 is actually this number here. To make it easier, let's just remove all the decimals, so you can actually see it straight away. So it's number 28. Oh, it created new random numbers. That's why I changed. Sorry. So it's actually number 28. So now let's try and change this a to be, actually, I'm just going to copy the whole thing, paste it down here, and just say from 0 to 2. And just run this. So this returns number 32. So how does this work? So 0, again, the first value is the row, so we want to stay on the first row, and the second value is the column, so it goes to number 2. So remember, it starts from 0, so 0, 1, 2 is number 32. That's why we have 32 down here. Right, the next thing we want to do now is to copy the same thing and replace the 0 with the column. And this is going to be confusing now. It confuses me too. So what we have here is the first 2 rows. So you can see all elements, so all 5 elements, but the first 2 rows. So the way column works, it says from until 2. So from 0 to 2. However, 0 now, it means 1 in this case when you use column. So remember, as I said here, the first value is the row, and then comma, the second value is the column. But we don't have comma here, we only have the first value. So if I add the comma, you can see that this is still the first value. So we are still on the rows. So we want to select from 0 to 2. But that 0 now, it counts as 1, from 1 to 2. So this is where it's confusing. When you have column, it doesn't actually mean 0, 1, 2. So it doesn't return the first 3 rows. It starts from 1, 2. So 0 to 2. I know it's very confusing, but I don't know why it's like that. So if you know why it's like that, please explain in the comments below. Right, the next thing we want to check now is A2 alone. So what this does is selects, now it starts from 0 now, because it does 0, 1, 2. So it actually returns the the third row. So 28, 9, 9, 44, and 39. Right, so we don't want this now. Let's assume that we want to select the last two numbers here. So how do we do this? So we have to say A and then open the square brackets. Remember, we start with the row, so the row is going to be 0, 1, 2. So A, 2, comma, and then since we need the last two numbers, so we have to say 1, 2, 3, 4. 0, 1, 2, 3 to 4. So if I say here 3 to 4, let's see what this is going to bring us. So it only gave us one number. Again, remember, because when we use colon, it doesn't actually start from 0. So what I have to do is say 3 to 5. There we go. So now we have the last two numbers. So let's say we want the first two numbers now. Again, we say A, open brackets. We start with the rows, so 0. And it's actually going to be 0 to 3 now. Because remember, colon doesn't start from 0, comma, and then we want the first is the row, or actually it's the row, sorry. So it should be 0, 0 to 3. And let's see, we get, no, I've done it wrong, 0 to 2. Oh my God, first two I said, not the first three. So there we go, 34 and 26. Right, so the next thing is that we want to try and select the middle 2 by 2 matrix. So let's assume that it's this one, so 80 to 73 and 9 to 44. To do this, we need to say A, square brackets. Remember, the first thing is the row. So the row is 0, 1, 2. So I'm going to say from 1 to 2. Let's say if this is going to work. 1, 2, 2. No, it should be 1, 2, 3. There we go, because again, remember, it doesn't start from 0. And then comma, we want 0, 1, 2, 3, 4, but it should be 2 to 4. So let's say 2 to 4. Let's run this. Okay, there we go. So we have 80, 73, 9, 44. Again, this is confusing. So if you don't get this right the first place, you can just play with the numbers until you get the right data from your matrix that you need. The last thing one is a 3 by 3. So let's assume is this one, 1, 2, 3, 1, 2, 3, 1, 2, 3. So again, we need all the data. So A, I'm going to say square brackets 0 to 3. So this is going to select the first three rows, as you can see, basically the whole matrix, and then comma 0 to 3 again. So as you can see, it filters out, it indexes the whole array to a 3 by 3 matrix. Right, the next thing is the array data types. So let's assume we need to create a NumPy array of 1, 2, 3, and then we run this, and then we type in a.dtype to check. As we can see that NumPy has chose the data type to be integer 32 itself. So if I copy the whole thing now and paste it down here and change the 1, 2, 3 to 1 dot, and then 2 dot and 2 dot 3, and then we run this, we get an error, which is basically, you can see I didn't start from the beginning. So if I run this again, I don't know, Python is so weird. I get the data type of float 64. So because I have the dot, again, NumPy has chosen the data type for me. But if I want to force a specific data type in, I can again paste the whole thing and say, again, we have 1, 2, 3. But this time, I want this to be a float. So 1, 2, 3 on the first cell, it gave us an integer. But I can say here, comma, dtype equals, I can either say np.float, I think this works. You can see it gave me a float now, or I can just say equals brackets float. Is this going to work? This, yeah, both ways work. I remember this correctly. Right, the next thing is the NumPy array basic maths. So this is where it gets interesting. These are things that you're actually going to be using on your day-to-day work as an analyst or data scientist. Right, Let's create now two arrays where we're going to apply months on them. So NumPy dot array, and I'm going to say this is 1, 2, 3, 4, 5, 6. This is my A, and then copy paste. This is my B, and my B is going to be 7, 8, 9, 10, 11, 12. Right. The first thing we want to see now is the sum. So if I do A plus B, click enter, I get an error because I haven't run the first cell. So I run the first cell, I run the second one again. So we can see that the mathematical functions operate element-wise. So this means the first element of one array with the first element of the B array. So 1 plus 7, we have 8, 2 plus 8, we have 10, 3 plus 9, we have 11, etc., etc. Now, A plus B is actually the Python method, let's say. If you want to do this through NumPy, so you're going to achieve actually the same result, you can say NumPy dot add A comma B. We run this and we get exactly the same results. Right, the minus now, I can say A minus B, control and enter. I get all minus 6s, and this is because I've used continuous numbers. So 1 minus 7 is 6, 2 minus 8 is 6, etc., etc. Now to achieve this through NumPy, I can just say NumPy dot subtract, and then A and B, A comma B, enter. I get not 1. So you've seen, let's check what I've done here. I've done 1 minus B. So what this has done is taken 1 minus 7 minus 6, 1 minus 8 minus 7, 1 minus 9 minus 8. So you understand how it works. But what I really wanted to do in the first place, it was A minus B, which is the same as the A minus B up here. Multiply now is as simple as it looks, A times B, enter, or I can say NumPy dot multiply A comma B, enter. Again, I get the same results. Division, I can say A minus B, enter, or division, what I have done, not minus, divided. I get these numbers, and then if I do NumPy dot divide A comma B, I should get the same numbers. So remember 0.14, 0.25. I click enter, 0.14, 0.25. Right, the square root now, I can simply say NumPy dot sqrt of A, run this, we get the square root of A, again is per element, or square root of B, and then again is per element. Now dot products now are a bit tricky now. I'm just going to create 4 different arrays so we can demonstrate how to do the dot product maths. So I'm just going to copy and paste the arrays, so we save time, and I'm just going to run them. So array A is a 2 by 2, array B is a 2 by 2, C and D are simple vectors of one-dimensional arrays. Right, the inner dot product now of vectors. There is 2 ways of doing this, one through NumPy and the other one through Python. So through Python, what am I doing? C and D. I can actually do C dot again, but actually written this time, and then in the brackets I do D, I click enter, and I get the number 23. I'm going to explain the maths in a second. The second way of doing this is by saying NumPy dot A comma B, is C and D, C comma D, I click enter, and I get the same numbers. Now the maths now, if you're coming to NumPy through MATLAB, are a bit different. They work element wise, as you've learned through school, and not matrix multiplication as MATLAB is working. So to understand the maths now, let's check the maths. So I'm just going to copy them and paste them down here, and I'm going to run C and D so we know what we have, or we do have C and D. So the way it works, we do 2 times 4, we have 8, so we get the first element of one array with the first element of the other array, plus the second element of first array with the second element times the second element of the second array. So 3 times 5, so 8 plus 15 equals 23. Right, the next example now is going to be a matrix times a vector. So we're going to do A and C. So again, the same way of doing it is C dot dot through Python, sorry, A and C. So A and then C, we get the answer of 8,18. So the answer is actually an array because I'm multiplying a vector with a matrix. And we can also do this by saying np dot a comma c. We click enter. Again, we get the same numbers. Now, to understand the maths, I'm just going to copy them and paste them so it's faster to explain them. So we take 1 times 2. So this 1 is here from A, and the 2 is this one here from C, plus 2 times 3. So 2 times 3 is going to be 2 and 3. And then comma, so this is actually our second element in our array, 3 times 2 with 4 times 3. So this is going to give us 2 plus 6 with 6 plus 11, and this is going to give us 8 with 18. So this is how NumPy is multiplying a vector with a matrix. The last example now I'm going to show is a matrix by matrix example. So quickly, let's do this. So A dot again, and then we want B. So the two matrices is A and B, 2 by 2 and 2 by 2. We run this, we get an array again of 19, 22, 43, 50. And another way of doing it is saying np dot a comma b. We should get exactly the same numbers. There we go, we have exactly the same numbers. Just to explain the math now, I'm just going to copy them and paste them so it's easier. Right, I'm also going to print A and B here so it's easier to understand the math. So A, B. Right, so let's try and understand the maths. So first I need to times 1 times 5, which is the first element of the first row of the first array, and again the first element of the first row of the second array, and then plus 2 times 7. So the second element of the first row of the first array times the first element of the second row this time, not the first row of the second array. And then I put comma, and this is going to give us 5 plus 14. So there we go. If we do the first two, and this is going to give us 19, which is going to be the first number that we have in our result. In the same way, we apply the calculations to get the rest of the numbers. So 1 times 6, so this is going to be 1 times 6, and then 2 times 8. So now you understand how the element wise works when you're multiplying a a matrix by matrix in Python. So this is going to give us actually 6 plus 16, and if we sum these together we have 22, which is the second element of the first row in our result, in our array result. Same way we apply the next calculations and we get to this result. Again, this is a bit confusing, but it's good to understand the maths before you actually start applying them in NumPy in Python. By the way, if you feel that you're getting enough value out of this video, please click that like button and subscribe to my channel. Right, the next thing we're going to cover now is the functions, the mathematical functions provided by NumPy. So I'm going to start by creating a new NumPy array now. And it's going to be a 3 by 2, so I'm going to have 1, 2, and then close it, and then I'm going to have comma 1, 2, no, maybe 3, 4, and close it, and then 5, 6. Then let's run A. Right, so we have a 3 by 2 array now, and let's say that I want to sum all the values that I have in the array together. To do this, very simple, I can just say np.sum and then A, and then I have number 20. So 1, 2, okay, 3, 4, that's why I didn't get 21. So if I run it again, I get the number 21. Right, sum the numbers by column now. So what I mean by that, I want to sum the first column, so 1, 3, and 5, and then the second column, 2, 4, and 6. To do this, very easy. Let me just remove this, we don't need it. I can just say np.sum. I want to sum A, and I can say comma axis equals 0. And if I run this now, it's only going to run the data by column. So it does 1 plus 3 plus 5, which gives us 9, and then 2 plus 6 plus 6, plus 4 plus 6, that's 6 plus 6, and that's 12. Now the same way, if I want to run the data by row, I can just copy this and then paste it down here and say axis equals 1 instead of 0. Sorry, I clicked something wrong. Control and enter, and now as you can see, I have 3, 7, and 11. So 1 plus 2, 3, 3 plus 4, 7, and then 5 plus 6 is 11. Right, the next thing I want to cover is the reshape. So you know how we have, let me just add another cell here. So I'm going to use this A array that we have here, and the shape of this A array is 3 rows times 2 columns. So let's say that I want to reshape this to have 1 row, 6, and then all the 6 numbers to be in 1 row. To do this, I can simply say NumPy Dot Arrange. No, what am I saying? Reshape. And then I can say 1, 6. So I actually want 1 row and then 6 columns. So A dot reshape. What am I saying? So as you can see now, we have the same elements 1, 2, 3, 4, 5, 6. But this time now is not displayed as a 3 by 2 like we have here. It's displayed as one single line. The same way we can do 3 by 2 is actually going to work too. Let's try it, 3 by 2, then we run it. Oh, it is 3 by 2, maybe 2 by 3. There we go. So now it created a 2 by 3. If I add a number that doesn't make sense, so 2 by 6, let's say, and run it, it's giving me an error because it's saying it cannot reshape a size of 6 into a shape of 2 and 6. So I'm just going to keep it as a 2 by 3 as it was. Right, the flatten now, I have shown this before in video 1, which is the H stack, if I remember correctly. We can say NumPy Dot H stack, and then we put A in it. So this is going to take any shape array that you have, and it's going to put it in a single array. So it's going to make it a vector basically. Right, the last thing we have here is that we can reshape the array while generating the new array. So for example, let's say we have A equals NumPy Dot Arrange 9. So what this is going to do, before I finish it, if I run it, it's going to create one dimensional array, so a vector that have numbers from 0 all the way to 9, all the way to, because it starts from 0 actually, it's going to have 9 elements from 0 to 8. So now, while creating my array A, I can just say dot reshape, and then I can reshape this into 3 by 3, right? Because 3 by 3 is 9. And if I run this now, you can see that it created the first, it created the vector here from 0 to 8, which is 9 elements, and then it reshaped them into a 3 by 3. I can also do let's say 10 here, and I can do 2 by 5. Anything that makes sense basically is going to work. There we go. Right, the next thing we have now is transpose, which is basically we want to turn the rows, so these are the rows, into columns. So like pivot the data, for example, or vice versa. To do this, I'm just going to copy the previous NumPy array we have here, and I'm going to change it to be a 2 by 2. So it's easier to understand. So if I run A now, so we have a NumPy array with 2 columns and 2 rows. And now I want to turn the rows into columns. So what I really want to see now, one way to do it, let's do it so you can actually understand it. I can say A dot T capital, so transpose and run this. So what we see now, it took this 0 and 2 and it turned it into 0 and 2. So it took the first row, let's say, and it made it a column, so 0, 1. And it took the second row, 2 and 3, and it made it a column again, 2 and 3. Another way of doing this now is by using NumPy, so saying NumPy Dot Transpose, and then we say A, and then we run it, and we get exactly the same result. So I do click enter, I just get the same result. Let's try and do this by 3 by 3 just to help you understand this. So we run it, and then we run the transpose. So instead of having 0, 1, 2, 3, 0, 1, and 2 on the first row, we have 0, 3, 9, which is 0, 3, 6, which is basically the 0, 3, 6 we have over here. Right, the last thing we're going to show for this tutorial is broadcasting, which is basically when you want to apply calculations on different shapes of arrays. So let's say our first array, I'm going to copy this and paste it here and create a 5x3 array. And then print it so we see it. And then my second array, which is going to be b, is going to be equals NumPy Dot Array, and it's only going to be a matrix, a vector, which is going to be 2 by 2 by 2. B, sorry, I left the space. So as you can see, the shape of A is 5 by 3, and the shape of B is 3, 3,0, because it's a vector. So NumPy now allows us to apply calculations on these two different sized arrays. So if I want to multiply them together, I can do A times B, because I'm multiplying two arrays, and the calculation now is as follows. Is 2 times 0, 0, 2 times 1, 2, 2 times 2, 4. And then it repeated the same process for all the rows in our array. This is actually extremely useful to use as a data analyst or a data scientist, because let's assume that your second array is going to be the measures that you want to apply to your first array, and you want to weight them differently. You want your first measure to weight very strongly, so 5, the second medium, and the third one nothing at all. So keep it as 1 as it is. And then if you run the calculations now, you can see that it adjusted based on what you have in your second array. Also, you can do A plus B again, which is going to be as simple as it sounds. It's going to add 5, 2, and 1 into every single row that we have in our first array. And also, something else which is very useful, you can apply calculation to every single element within your first array. So you can literally do A divided by 100 times 2 and click enter, and it's going to apply this calculation to every single element in your array. Right, so this is it for this tutorial. I hope you enjoyed this tutorial and you now know how to use NumPy in Python. If you did enjoy this tutorial, please click that like button and subscribe to my channel. Additionally, I'm going to be doing pandas, matplotlib, and then machine learning tutorial. So make sure you enable that notifications bell so you know when I'm going to be uploading new videos. Also, if you have any questions, or if you feel that I haven't explained something very well, or if you need more examples on a specific subject, please let me know so I can make a video about it, or I can answer it in the comments below. If you want to learn more about NumPy, I have added this link here, which has a lot of information around NumPy. It goes way deeper than what I've covered, but I think what I've covered is enough to get you started as a data analyst or a data scientist. Right, thank you very much for watching.